Okay, so what is everything or anything that you can tell me about this periodic table?
There's a lot of them.
There's a wait. There is a couple blocks.
Just tell me.
Their number shows how many neutrons.
Well, that's pretty vague. Okay, so what does that mean when you say shows the number of protons?
Their atomic number shows how many protons they have in their nucleus.
And that's also important for something else, the atomic number.
Electron.
Well, yeah, but like for instance, if I ask you, tell me element 33, element 33 means that's the atomic number, so what element are we referring to?
Arsenic.
Arsenic. So when you hear that number, you say that is the atomic number. That identifies that element, okay? So element number 3. Okay, so what else can you tell me about lithium? Because it's element number 3, you should also be able to tell me something else about lithium.
Lightest element.
No.
Wow.
How many protons does it have? It's got 3 protons. Okay, that gets to be a little tricky because the atomic mass of lithium is 7. Okay, so if it's neutral, okay, if it's neutral, okay, how many protons? Okay, how many electrons?
4.
How many electrons?
4.
Okay, how many neutrons?
4.
And how did you get 4?
7 minus 3.
Okay, 3 minus 7, or no, 7 minus 3. I always got to think about that too. Okay, so what is this type of arrangement called? Periods. Okay, what is this type of arrangement called? Columns. Okay, how many blocks are on the table?
Too many.
118.
How many blocks?
2.
How many blocks?
Oh, like 1, 2, 3, 4, 6.
How many blocks?
5,
How many blocks?
6.
What is it?
How many blocks?
What block?
4. What are your 4 blocks?
S,
S, P, D, and F. Okay? So, from yesterday, go ahead and pick a number between 1 and 8.
7.
So we heard 3. Okay? That's the first one I heard.
How do you spell columns?
C-O-L-U-M-N-S. There's a silent N in there. Okay, so when we're talking about column 3, okay, boron is in the 3rd column.
No. Wait, what?
Boron is in the 3rd column.
Where?
This isn't our living room,
Oh. What?
okay?
Where?
Boron is in which column?
3.
Yeah, because you picked the 3rd one, correct?
Yep.
So how do we know that, other than you said that it's 3, okay? How do we get the 3rd column? By looking at this table.
Right on top of it.
It is.
Number 3 is on top.
Yeah, it sits right on top of there. Go by the letter A, all right? Don't go by 13. Don't go by 3A, Roman numeral 3. Just use the number 3, okay? So now, would you want to see boron or aluminum, because those are in the same column? Okay, so if we were looking at boron then, okay, very quickly. Okay, how many protons are there? 5, right? So 3 is important, because if it's in the 3rd column, that must be important because we do follow the slide rule. 1s what? 2s, 2p. Okay, we said 3 was important, correct? So this would help you identify where it's at because it's in the 3rd column. 2 plus 1 gives you 3.
How do
Okay.
you know if it's A or B though? Because like there's 3B and there's a 3F.
Okay, where do you see 3B?
Above
The D
scan
block.
Okay, what did we say about when it comes to the D block?
I don't know.
You skip the D block.
Why?
Okay. In that video, okay, it said, what's true about chlorine? What column is chlorine in? Or, I'm sorry, fluorine. In the 7th column. Do you suppose that's important? Yeah.
Possibly.
Oops. 9. Okay. 1s2, 2s, 2p what?
5. Oh, I'm so smart.
Okay. Now, if this is fluorine, which it is, okay, 1s2, 2s2, 2p6, 3s2, 3p what? 3p what?
2.
3p what?
Oh, is it nothing?
3p what?
6.
Oh, 5. I thought it said 12 up there, my bad.
Okay. What is 6 plus 6
12.
plus 5?
I thought it said 12.
17. Okay. Then we can go one bigger. Bromine. Okay. What column is bromine in?
Bromine is in 7.
It's in the 7th column. Okay. 35, right? Okay. 1s2, 2s what?
2.
2p,
6.
3s2, 3p.
6.
Okay. Then what?
Another. 3, 2,
Okay.
10.
Okay. Then it's 4p what? What does this, and this, they have something in common?
Equals 7.
They all add up to 7 because these are halogens in the 7th column. Okay? So what that means, when we did that bromine, which is right here, correct? Did we say anything about these D block elements?
No.
No, we did not. We accounted for them because they are right here. Okay? We've never said anything about the letter B. Ever. Okay? So we said when we're looking at these valence numbers, you go by column 1, column 2, column 3, 4, and all the way up to 8. So if we say, give me an element in column 5, there's a whole bunch you could give. Nitrogen's 1. Okay, that's probably on the bottom. Little heavy. You also have phosphorus, arsenic, antimony, and bismuth. Yes. Okay, column 5. Makes sense? Okay. So, as we proceed forward then, okay. So this is where we left off with last time, okay? So if we were talking about isotopes, okay, if we had the number 8 here, the atomic mass for lithium, if we said it was 8, which one of these 3 numbers would change?
Neutron.
Why? You're right.
So it'd be 5 instead of 4.
It would be 5. Correct. Because isotopes, okay, atoms of the same element that has different numbers of neutrons. Okay? So that means this number, you still have the same element, still lithium, Just the atomic mass is different because it has one more neutron in it. This is where we left off with last time, correct? Okay? Because I know some of us are writing this. This material was on the Science Channel, which is neither here nor there. So for students who are gone today, they still have that opportunity to go back and watch this. Same goes for you young men and women in here. Okay? So, new material. Okay? We've been dealing with this for, well, a little over 2 weeks. Okay? When you look from left to right, okay, those numbers increase by an exact increment of what number?
1.
Of 1, exactly. Notice it's not 1.01 and then 2.02 and then 3.5. No. Every time that increases by an increment of 1, it's one more what? In other words, if we change 3 to 4, now you're talking about beryllium. How would you know that? Because the atomic number for beryllium is what?
4.
Then if we go to element number 5, 5 protons, that is what element? Boron. And then to carbon, then to nitrogen, then to oxygen, then fluorine, then neon. Each and every one of those cases, you're increasing by an exact number of 1. Okay? And these patterns all down the table. Okay? And that's why we have the periodic table, because they repeat themselves. Now you have to look at Mendeleev, his first table. How was it arranged? It says atomic mass, which we know now is incorrect, but why was that such a wonderful application of the periodic table? Does anyone remember approximately when Mendeleev was working on these?
1880s, 1890s.
A little earlier than that. I want to say 1850s, 1860s was the approximate time frame. And are we just soaking this up? All right. Just like a peripherin, right? Okay. Of course, it would help if we said a peripherin's a sponge, so you're soaking this up like a sponge. Do you know what that means?
Yep.
What does it mean?
Gathering all the information in my head.
Okay. But how? What does a sponge do? Soaks things up, right?
Yep.
Okay. All right. So
SpongeBob before.
this, I don't even know how to reply to that. All right. All right. Now, if you don't have to, if you choose not to write this down, that's your choice. But this helps me explain this content to you. I guarantee you that a couple of vocab terms you're going to see tomorrow is going to be this one, and I guarantee you it's going to be this one. How are you going to be able to tell the difference? If you write it down, I bet you that helps you out. But if you choose not to write it down, that we're young men and women in here. We're in high school. Okay? It's choices that we make. Gesundheit. And would you be more comfortable outside? So if we're not going to write this down, we shouldn't even know that you're here. I understand we sneeze. We said Gesundheit, which means bless you in German. We shouldn't even know that you're here. Okay? Because notice, no one else in here is making 4-year-old noises except for yourself. Am I wrong? Someone just jump in and tell me the old man's wrong. Okay? All right.
How is it like, so, like, each one follows after the other? Like, how is it always, how is it not a decimal? How is it always just one whole number after the other?
Because we said you don't typically consider partial neutrons. So when we say that, that's why this is 7 and not 7.00 whatever. It was just established that when you're talking about protons, it's not going to be a partial number. It's just going to be an increment of 1. Electrons are always just going to be an increment of 1. It's just when you weigh the heavier elements like oxygen, which you might say is really not that heavy, but when this periodic table was established, it was 8 times heavier than what? Hydrogen, the lightest element, okay? No, I'm sorry, not 8 times, 16 times. So the atomic mass of oxygen must be what? 16. Okay? So, and that's the best way I can explain on how it's point whichever. Okay? So when you weigh that on a balance, it comes out to, on the table it says 15.9999. Anyone who's done general chemistry is going to say, we just use 16. Okay? All right. One of the aspects that the author goes on to talk about that I think it's too much content to put into this chapter, okay? And it has to deal with this concept, okay? Because when you look at any one of these elements, it says group 1, okay? Hydrogen, lithium, sodium, potassium, rubidium, francium, they're all in column 1, okay? Then you jump next door and you say, okay, let's look at beryllium, then what is it, magnesium, then calcium, strontium, and then barium. Is that right? Yes, and then radium at the bottom. Okay, so predictions that you can make on this periodic table. What did the host and the narrator say? It's a table that is arranged and explains a lot of things when it comes to subatomic particles if you know how to use it, okay? The reason that you don't know how to use it that much yet is because you haven't been taught that yet, okay? So if we were to, for those of you in not so much one-act play because it just isn't long enough, when we talk about the spring play, okay, which you're working on tomorrow, correct? Are you list? I can't remember for sure. Are you gone tomorrow? Who else in 2, 3, 4? Okay. So in actual play terms, okay, on the stage, what does it mean to foreshadow something? You know what that means? Something in the future, okay? So we'll do a little foreshadowing here, okay? Because we've done it, you just don't realize that you have, okay? So for instance, this foreshadowing, these 3 elements, we said, they've got something in common. What is it? Right. Why do you suppose that's important? They must be in which column? So we're looking ahead in the future, that foreshadowing, okay? Because it's in column 7, it's got 7 valence electrons. If this element, boron, just by looking at this, you don't even have to look at the periodic table. I would expect that now you can tell me what column is boron in.
3.
Right. And why is that?
Because it has 3 Valence.
It has 3 valence electrons. Okay? So then when you look at carbon, how many valence electrons does it have? How many valence electrons does it have?
What is that? What is it?
Carbon.
Four.
It's got 4 valence electrons. Then when you look at nitrogen, how many valence electrons? 5. Because it's in the 5th column. So that same concept applies to these groups. Okay? Because I'm willing to bet it's going to tell you that yeah, elements within the same group have similar properties. Okay? Levels are numbered from 1 to 7. They introduce electron dot diagrams. We do that next chapter because there's 3 main topics they put in here. Bohr models, you've done those. Electron configurations, you've done those. The author chooses to put these in here, but I think that's too much. We save that for later. Okay? So then getting back to this, these predictions that we see, when you go from group 2 to 3 to 4, all the way up to 8, the column that it's in tells you something very important. What a valence electron is and how many are there. Okay? The reason that you might think that this is a little difficult is because this is brand new material. Okay? We'll get to the end of this slide, and then for this portion we will stop for today. Okay? Because we didn't have time this week, but one of the activities that you'll do next week, okay, is illustrating Bohr models. You actually take pieces of Skittles and then illustrate a Bohr model. That's the first activity that we do in here. Okay? It's just a visual depiction upon what an atom would look like. Okay? So yes, we do some of these hands-on activities, but we just don't have enough background information for that yet. Okay. So does everyone have this content that wants it? I heard I don't. Oh, okay. You heard the word Skittles and it just threw you off course.
I go through the Bohr model on the last element. I don't know how to say it. I know it's so good.
Okay. So, we're not writing anything. We're just looking at what this says. Okay? And let's just follow along on this table on what it says. Okay? You start with the first column. Okay? These all have something in common. They've got one what?
Valence electron.
Okay. These have how many valence electrons? Okay. Then what does it tell you here? Skip. So that's that letter B that you were referring to. You skip those. Okay? Because those are transition elements. And one of the things you could do to answer that question, okay, I'm going to, like, for instance, pick on yourself. When you look at, for instance, element 24. What is 24? Chromium, right? So does chromium have only one type of charge, a positive something or a negative, or does it have 2 different charges? Okay, that's why you skip these transition elements, because they've got more than one charge. These only have one type of charge. These only have one type of charge. Some of these have various charges, and then for the most part, you go by the top element in that family or group. Okay? Well, it just depends if it has a +1 or a +3 charge. Okay? But really, when you look at it, it's actually got, let's see here, that would be, what's 5s2, So it's got 2 valence electrons. Okay?
What about the ones at the way box?
These down here, that's a little too far up the chain for you individuals at this level.
Good.
Okay? Because these are rare earth elements. Okay? And yeah, we don't want to go into that. We don't discuss those much at this level. Okay, so that's all I have. You have a paper that's due. You have about 7 minutes to work on that. Then make sure your names are on them, and I will collect them.
Can I get one of them? I lost some.
And then, let's see here.
When's the vocabulary?
Tomorrow.
Mr. McKinney, can we get out our mobile devices,
Okay, I'm just thinking because it says on the schedule to hand out worksheet 2, but it would appear that some of us are a little overwhelmed with worksheet 1. But one of the things that perplexes me, just a moment, and I want to know this for my own benefit. On the back side of this, did we do one of them together? So if we did one of them together, can someone explain why you would not write that down? We did it together in class. So why would you not write it down? I don't know either. Okay, we'll catch up to you next time. I will hold on to that paper and I will hand out tomorrow. Vocab quiz tomorrow as well. We'll catch up to you next time.